Hello guys. After a small break, I'm there back with you. Welcome to my YouTube channel, Salim's Learning Simplified. Today, I'm there in front of you with a small topic. We have to cover three major things in today's discussion. Number one, what is a test cross or otherwise called as back cross? Number two, we are supposed to solve two problems which are looking almost alike, but exactly how to solve such problems. Before getting into the topic, let me give an idea what the questions are basically asking us. In this problem 1, when we check carefully, we can see dihybrid cross genotypic ratio given round yellow 3 and round green 1. Problem number 2, same dihybrid cross genotypic ratio is given round yellow 3 but wrinkled yellow 1. In both cases, find the genotype of the parent. This is what we are going to check today, and welcome. Let's start. First of all, what is test cross? You all must have heard about Gregor Johann Mendel doing such beautiful crosses in pea plant, and there in his monohybrid cross he selected tall plants crossing with dwarf plants. As you all know, what happened, he stated that there are two kinds of tall plants. A tall plant can be either having a genotype of capital T alleles or of genotype of capital T small t alleles. So when you look at a plant, what we see on the plant is called the phenotype. So I'm just seeing a plant. Can you say what is your genotype? No, I can see a phenotype. You're tall, of course. For dwarf plant, I have no doubt. Why? Because dwarf means certainly both the genes are dwarf. For dwarf means both the genes are recessive. So I have no worry about that. Let me explain a little more. So as you know, the alleles can be either dominant or recessive. Here we go. In the case of tall, we can either write the alleles as a pair of both capital letter T's, or we can write as a pair of a capital letter T and a small letter t. By the way, you guys know that this capital letter T, if both a capital letter, we just use the term homozygous. And if it is different letters, okay, certainly as we usually know, heterozygous. Okay. So guys, listen. There is a pea plant. It is tall. Mendel want to do the cross with this plant with a dwarf plant. But he must know exactly whether this is a homozygous tall plant or a heterozygous tall plant. Am I right? The plant is looking tall. But if you go and read, can you read on the leaves of the plants, I'm homozygous, I'm heterozygous? No. And during those days, he was not clear about what are genes and this kind of stuff. So, we know that he has done a cross between a tall plant which is pure line. He called it by a term pure line. That means homozygous. The term he used was pure. The term he used was pure line. Pure line, or also called true breeding. So this was the term he used, pure line or true breeding. So how did he make sure that his plant is pure line, his plant is true breeding? I mean, how did he understand that the tall plant which is standing in front of him is actually capital T homozygous? Imagine that he used a tall plant which was capital T small t. Complete history could have been gone somewhere. So what is the mechanism he used to understand whether the tall plant is capital T or with the alleles capital T small t? For that, he devised a special cross and he named it as test cross or back cross. Let us check it out. What is a test cross? Why is it called as a back cross? Let me get very simply into the topic and then you will understand exactly how to make a definition of a test cross. Look, what is the scenario right now in front of us? I have a plant. I have very clear idea about whether the plant is homozygous or heterozygous. Sorry, I have the clear idea whether the plant is tall or dwarf. The phenotype I know. But do I know the genotype? No. I don't know whether the plant is homozygous or heterozygous. So, I need to find the genotype. The plant has hidden letters. The genetic constitution of the plant is genotype. I need to find the hidden genotype of a non-height and everything we know. That's called phenotype. A non-phenotype. I repeat, to find a hidden genotype of a non-phenotype. To find an unknown genotype of a non-phenotype. Yes, that's it. Here we go. A cross devised in order to find the unknown genotype of a non-phenotype is called test cross or back cross. By the way, why it is a back cross? Let us check it out. In the test cross, there are two scenarios. We have to do cross 1, cross 2. Okay? So, here we go for cross 1. And other side we'll try cross 2. So, let's go guys. In cross 1, what is it? He just took the tall plant. He doesn't know whether it is homozygous or heterozygous. For the time being, let's imagine it's homozygous tall. Both the letters are capital T. And he crossed with a homozygous dwarf plant who has both the alleles small t. Alright. So, he doesn't know whether this plant is having homozygous means capital T or capital T small t. He doesn't know. He's going to find that. How? Let's check out. Now, if we work out this cross, these are the gametes they are going to make. And as you know, the gametes must have only half the letters of the alleles. Alright, and the F1 generation, all the offsprings that he took from this will have a capital T and a small t. And law of dominance says, what? Law of dominance says that if at all there is one allele dominant, he will express and the other one will suppress. So here we have an allele dominant, of course, that is capital T. So he is going to express and small t cannot show its property. That means this plant is going to be tall. 100% of what his F generation comes to be tall. F1 generation. Let's imagine, by the way, while crossing, he has used a heterozygous tall plant, okay, with a dwarf plant. As you already know, that dwarf plant is double recessive or both the alleles written here are recessive and they're very pure for their character. Here we go. What's it? This one is impure. That plant can make two kinds of gametes. Either a capital T containing gamete or a small t containing gamete. But the other dwarf one can make only one gamete. And let's go ahead. Here we can get two choices. What are they? Capital T, sorry. Capital T, small t, and small t, small t. So, look, if the parent plant he took is heterozygous, he is surely going to get 50-50 tall and dwarf. So as you know, this genotype is expressed as tall and this is expressed as dwarf. Alright, so he's going to get 50-50, 1:1 ratio of tall and dwarf. So now guys, it's very clear. What is a test cross? He has crossed the plant. He doesn't know which is the plant. But at the end, he didn't care what is the plant's what genotype at the start. But at the end, he checked the results. If 100% of the babies, the F1, the offsprings came out as tall. I'm very sure the plan which I took is homozygous tall, means both the adults are same. Imagine the offsprings came as 50-50 tall and dwarf. That means it's very clear that the plan I have taken for crossing is having two different letters, and that is capital T, small t, heterozygous tall. So our Gregor Johann Mendel didn't go to the plant and check on the leaves whether you're homozygous or heterozygous. No, never. What he did, he just did this test cross, and got the result. Based on that result, he came to the conclusion that yes, this is my plan. And of course, as you know, he must have taken this result plan, this plan where he started with that plant as the father or what the parent for his monohybrid cross. So this is how an unknown genotype of a non-phenotype is being found out. By the way, one word still remaining with us. What is it? Why is it called a back cross? Yes, guys, let us get into that. Look, in monohybrid cross, you all must have studied that the cross is done with a tall parent and a recessive, small t, recessive parent. So now we are checking this plant by crossing it with the parent which was used in the monohybrid cross, as you all know. And that particular parent, once the parent is crossed with the offspring, I repeat, as the offspring is crossed back to his previous generation, to the parent. When the offspring is crossed back to the parent, that's why we could call it as a back cross. Hope this concept is clear for you. Now we have a challenging question. What is normally challenging in this? You know, people normally understand that 3:1 ratio is monohybrid cross. Of course, no doubt. But then the question is specifically telling us it is a dihybrid cross, means you are supposed to take two sets of characters. And in the dihybrid cross, genotypic ratio is given, round is 3, round yellow is 3, round green is 1. Here is another question, round yellow is 3, wrinkled yellow is 1. So question is saying us, in both this case, work out the probability of these babies or F1 offsprings, and try to understand what is the genotype of the parent. Okay, by the way, this kind of questions we are not solving with any test cross, rather we can use another method. And I have seen such videos are less available, that's why I thought of giving some idea about this. Let's get into the topic. Yes, guys, here we go for the topic. What is it? In a dihybrid cross, the genotypic ratio is given as round yellow 3 offsprings, round green 1 offspring. Round yellow means it can be capital R, capital R, capital Y, or capital R, capital R, capital Y, small y, or capital R, capital Y, small y. Am I right? So it can be any of these three. I repeat, what are they? Round yellow. The concept of round yellow could be either of these three. Capital R, capital Y. Capital Y, yes, of course, round yellow. Capital R, capital Y, small y. Yes, of course, round yellow. Capital R, capital Y. That's of course round yellow. And we can even have capital R, capital Y, small y. So which one is the parent? That is our question. And now there is another one. These 4 kind of offsprings can become, not a parent, can become the offspring. Now we have a round green. So let's go for that. There is the clue for us. Here we go, guys. Round green can be capital R, small y is a must. Why? Because it is green. Or we have one more choice. Okay, let's go ahead for that choice. What is it? It can be capital R, small y, small y. So now the ratio is specifying 3:1. How to solve such questions? Come on, here we go. First of all, draw a checkerboard with 3:1 ratio. That means we need 4 boxes. A Punnett square with 4 boxes. And after drawing that, one part is very clear for you. You are supposed to get what? Capital R, small y, 1, round green. Okay, let me suggest you to take this, as this has what? Complicated letters. Let us try working out this as what? Round green. Out of the 3:1, let me put this round green individual here. If I have written there round green, the gametes which make that has to be here like this. Hope this concept is okay with you. All right. So the gamete making this particular combination must be heterozygous, capital R, small y, then only I can get the 2 parents giving this concept. Now, remaining 3 members in our story is what? In our question is round yellow. So let's go. Round yellow, what are the possibilities we can use? Let us try using what? Imagining that this plant, see, the first plant that we used here has to be what? We don't know what is the father's or mother's genotype, but has to have these 2 letters. So when I write all the 4 letters, here we go, capital R and 1 small y I have written. Now, what am I supposed to find? Whether it is capital R, capital Y, small y, or capital R, small y. I'm just keeping capital R like that for the time being. Let's work out as capital R. If capital R, small y is the condition of that plant, what will be the 2 gametes produced from that? It could be one choice, capital R, capital Y only. So we cannot take that because we need 2 gametes here, 2 gametes here. This particular parent can give only 1 gamete. So I'm sorry, we are not going to take that. So instead of that, we will try the next letter. Hope you are getting the point. So in this case, we can have a gamete of capital R with capital Y and another gamete with capital R with small y. Yes, here we have a capital R with small y. Even here also we have a capital R with small y. So just let's imagine what one among the parent is like this, double capital R, capital Y, small y. And here we go for that parent taking this part as capital R, capital Y and capital R, small y. So we suggest this is the genotype of one parent. Now, by this we can work out some more generations genotype. What are they? This we can go capital R goes with capital Y, small y. Here we go, isn't it? Now, what is remaining with us? We have to find 2 more where we should get round yellow. So that means to get round yellow, here there is what? There is a choice already. What is the choice in this column? We have a small y and capital R. Let us work out the same probability, the same the genotype for the parent. That means we can get these 2, right? Okay, so capital R, small y. So if I write capital Y here, what will be the condition? Let's work this one out. Capital R, capital Y, capital Y, small y, then capital R, capital Y, small y, capital R, small y. So this is round yellow, and round green. And we have come across our 3:1 ratio, round yellow 3 and round green 1. That means the parents that we use for this cross is, what is the final answer? That parents are having the genotype. Okay, there are so many probabilities. We are just working out one probability in that. And that probability of this one is capital R, capital Y, crossed with another capital R, capital Y, small y. Sorry, here I pronounced capital Y, that's small y. I'm sorry for that. So that is the answer for the first question. Now we should work for the second question. Here, this is round green, but here it is wrinkled green. So there is a cheat in that. Let's go ahead. Normally when we see this, we feel like it's a monohybrid cross. No, it is a dihybrid cross, very clearly told dihybrid cross, 3:1. From the 3:1, 9 and 3 gone, remaining 3:1 is only there with us. So let's work out the second question. Moving to the second question. Problem 2, round yellow 3, wrinkled yellow 1. So I need to get the F1 as round yellow 3 individual, which can be capital R, capital Y, or capital R, capital Y, small y, or capital R, small r, capital Y, or capital R, small y, small y. Any of this combination I can take. Now the second is wrinkled yellow. The F1 second child is wrinkled yellow. The second offspring is wrinkled yellow, and that is 1. So in wrinkled yellow, there is a clue for us. In wrinkled, we cannot have capital R, as it is a recessive. It must be small r, and yellow could be capital Y, or even capital Y, small y. So how do we proceed? This is what we are seeing in our mind before we start. As we have 3:1 ratio, go ahead, come on guys, like previous, let's draw alternate square, a checkerboard with 4 boxes, and let's here put the male and the female. Sorry, in the previous cross I didn't do that. And here we know that one among the children is surely wrinkled yellow. So it should, let us take for the time being, this is our wrinkled yellow. Alright, so to get that wrinkled yellow, I'm just going to write the genotype directly there. So from here we have already got what are the factors or alleles in their gametes. So it has to be a small r, capital Y here, another small r, capital Y here. Alright, now next 3 we are supposed to get round yellow. So with the small r, capital Y, how do we get? That's a question. Let's imagine our parent is like this one. We can have what? From this many choices are there. I'm just taking one choice. Alright. If I take the previous one, I have just tried the trial and error method. Here directly I'm getting into what? Because I know both the letters, if they are capital R anyway. Okay, let me try that. If both the letters, I'm going to be taking capital R, for sure one of this will become capital R, capital Y, isn't it? And there will be only one kind of gamete produced, but we have 2 gametes slot here. So it's not going to be capital R, capital. Let us go for capital R, small r. So when we try that, how is the ratio going to be? Capital R, small r, capital Y, capital Y. So here we go. We have 2 gametes, which are the capital R, capital Y, and small r, capital Y. So small r, capital Y is written by both of them. Let us work out capital R, capital Y here, both the sides. Okay, so what is it? Here we got capital R, capital Y, it's round yellow, capital R, small r, capital Y, again round yellow, we have capital R, small r, capital Y, again round yellow, and small r, capital Y, small y, which is wrinkled yellow. So what is the clue? Let me rewrite the answer over here. We have this as the genotype for both the parents. So our cross will be looking like this: capital R, small r, capital Y, cross with capital R, small r, capital Y. So in this question, imagine you got one more clue. Both the parents had the same genotype. It will be so easy to come to this answer, isn't it? Imagine this question is saying both the parents cannot cannot have the same genotype. That is a bit confusion, right? You will have what? Butterflies in the stomach. So, how to get that solved, I will see you in the next video. Till then, bye. See you for the next video. Bye.